All right, if you would please turn your textbooks over to page 219, and we're going to start with activity 4.1. Again, that is page 219. All right, percent increase and decrease. So you have used percents in many different situations. You can also use percents to describe a change in quantities. A percent increase occurs when the amount is greater than the original amount, such as when stores mark up the price they pay for an item to make a greater profit. Okay, so let's just do some work here. Number one, all that Glitters jewelry store marks up is, okay, marks up its prices so it can maximize its profits. What is the percent increase for each item? Use the formula shown to complete the table. All right, so I've got percent increase equals the amount of increase over the original, which in hindsight 2020 means difference over the original. Okay, that's what you'll hear a lot of the times. All right, so let's take a look here. I have an initial ring. So initially, my original purchase price is this right here. So this is my original. Okay, and this here is my new. All right, so to find the difference, I'm going to do the new minus the original. So I'm going to do 90 minus 60, and that's going to equal 30. That's my difference. Now, to find the percent increase, I'm going to use my formula here of difference over the original. So I'm going to have 30 over 60. Well, 30 over 60, that reduces to 1/2, which that is 50% markup. Okay. Number two, or the second one, ID bracelet, it is 240 minus 120. Okay, 201. Well, to find the percent increase, it's going to be 120 over the original 120. Well, that simplifies to 1, which that tells me it was a 100% markup. Okay. Now, for the third one, it was 50. So 50 minus 25 gets me a 25% difference. So 25 over 25, well, that's equal to 1, and that's a 100% markup. Okay. And then my pin, it was 45 was the new price. Originally, they paid 36 for. Okay. So there's a $9 difference. So I'm going to do 9 over 36. Well, that can be divided by 3. Okay. Well, 9 divided by 3 is 3. 36 divided by 3 is 12. That can be divided by 3 again to have 1 over 4. Well, 1/4 as a percent or as a decimal is 25%. Okay, 25%. All right. Here we go. The next one, I have percent decrease. So that was a percent increase. Then you have a percent decrease. So a percent decrease, it occurs when the new amount is less than the original amount. Okay, an example of percent decrease is the amount of water evaporates over time. Water evaporates at different rates depending on the size and shape of the container it is in and the air temperature. All right, so a science class is conducting an experiment to determine how fast water evaporates. They fill 4 differently shaped containers with water and measure the level once at the beginning of the experiment and once at the end. Use the formula shown to complete the table. All right, so percent decrease, it looks like an amount of a percent, so it's still going to be difference over the original. Okay, you're going to use the exact same equation you would for percent increase. Now, the only difference between these two things is when you find it, you just need to tell me, did you go up or did you go down? Okay, increase or decrease. Now, our first column, remember, this is our original column, and this is our new. Okay, so to find the difference, I need to take the new and subtract the original from it. So I'm going to do 7.1 minus 4.5. Okay, so 7.1 minus 4.5. That's going to give me 2.6. Let's go ahead and do the rest. So 2.3 minus 0.9. That's going to be a 1.4 difference. I'm going to have 3.8 minus 2.9. So 3.8 minus 2.9. That's a 0.9 difference. And then I have a 9.2 minus 7.6. And that's going to be a 1.6 difference. Now, in order to find the percentage, I'm going to take the percent or the difference over the original. Okay, so I'm going to do 2.6 over 7.1, 1.4 over 2.3, 0.9 over 3.8, 1.6 over 9.2. Okay, and I'm using my calculator to help me out here. So I'm going to do 2.6 divided by 7.1. And this roughly is going to be a 37% increase. 1.4 divided by 2.3 is going to be a 61%, or this is decrease. Sorry, this is decrease, not increase. Divided by 3.8. This one is going to be a 24% decrease. And then 1.6 divided by 9.2, it's going to be a 17.4% decrease. Okay, now these numbers here, I just rounded them up to the nearest whole or the nearest tenth. Okay. All right, number 3. How do you know if the percent is a decrease or an increase? Well, you know when your new number is either bigger, increase, or smaller, decrease from the original. Okay, so when your new number is either bigger, increase, or smaller, decrease from the original. Okay, so how would you describe a 50% decrease? Okay, I would describe a 50% decrease as half of the original amount. Okay, and how would you describe a 100% increase? Well, the new number would be double my original. The new number would be double my original. Sorry. All right. Number 6. Okay. So Jake was doing a great job at work. So his boss gave him a 20% raise. All right. Sounds pretty good to me. Then he started coming to work late. Well, and missing days. So his boss gave him a 20% pay cut. Jake says, that's okay. At least I'm back where I started. Is Jake making the same amount of money when he received a pay cut? If you agree, explain why he is correct. If you do not agree, explain to Jake what is incorrect with his thinking and determine what percent of his original salary is he making now. All right, so we need to figure out what's going on with Jake, and we need to see, is he increasing and decreasing at the same amount? Did he change? What's going on? Okay, so what do you think? Do you think he ended up right back where he started at? I mean, I'm going to say no, and that's what we're going to figure out. Okay, so here we go. Let's see here. What did we say? We said no. Okay, sorry. No, do not agree with Jake. Okay, and here's why. So say, for example, like you earn $100,000 a year. Okay, so you take a 20% pay raise. All right, so I'm taking a 20% pay raise, which means, I have 100% of my salary right now. I'm taking a pay raise of 20%. Okay, so now I'm making 120% of what I was making. All right, this new number is now my new 100% salary. Okay, this is what I'm making now. Then I'm told that I'm going to take a 20% pay cut, which means now I'm going to take 20% of this number here. So say, for example, this number was 200. Okay, then if this number is 200, well, 200 times 0.20 is 40. This is now 240. Okay. Now I'm taking because 200 times 0.2 is 40. And then this is my new total. So now I'm making $240. Okay. So Jake's like, okay, well, a 20% pay cut. Okay, I'll go right back to 200 in this instance for this example here. And let's take a look. All right. So 240 times 0.20. Well, wait, that's minus $48. So what's 240 minus $48? Well, that's 192. Is he back where he started at the original 200? No, he's actually under the original 200. So he's going to be making less than what he started with before he was given his pay increase. Okay, so he lost money in that situation. All right, flip on over. We're going to skip a couple of questions, and I want you guys to go to page 223 for me. Page 223. We're going to look at 4.2, depreciation and proportionality. All right. So generally, things like homes and savings accounts gain value or appreciate over time. Other things like cars depreciate every year. New cars depreciate about 12% of their original value each year. And it gives us two vocab words over here. So let's look. Appreciation is an increase in the price value. A depreciation is a decrease in the price or value. So think about it when they say for cars. So say, for example, if your car is worth $50,000 when you buy it, okay? When you drive your car off the lot, is your car still worth the exact same amount? The answer should be no. The second that you drive your car off the lot, your car is no longer worth that much. Because if you think about it, when you go back to try and resell it, you can never resell your car for what you paid for it. All right. So I need to find how much would a new car depreciate the first year if it cost $35,000, $45,000, and $20,000. All right. So it looks like I have my total and I have my percent. I'm looking for my part. So I want you guys to pause this video for me. And I want you to take about 30 seconds and I want you to tell me what is each of these things here. What is my part, my whole, and my percent? All right, so my part is unknown. My whole is this number, 35,000, 45,000, and 20,000. My percent is 12 all the way through. Okay, so I'm going to use my equation, okay? For part equals percent times the whole. Just that way I have some working room here. There we go. I'm going to use my equation, part equals percent times the whole. Now remember, percent has to be written as a decimal, so this 12% has to be written as 0.12 to be able to be used in this equation. So part is going to equal 0.12 times 35,000. Part is going to equal, well, I'm going to go ahead and use my calculator very quickly, okay, because these numbers are really large. Now, when we give you guys tests and things, you guys aren't going to have these really large numbers. So part is 4,200. Now, it says it depreciates, which means I need to take my original and subtract my part from that. So 35,000 minus 4,200. My car is now going to be worth $30,800. Okay. Now let's try for the next one. Part is equal to 0.12 times 45,000. So 45 times 0.12. Part is equal to 5,400. So I'm going to have 45,000 minus 5,400. And this is going to equal 3 minus 4,500. Oh, I did that wrong. I did 54. Okay, hang on. 45,000 minus 5,400. And my new car should be worth $39,600 after the first year. Now, this is just in 1 year. So part is equal to 0.12 times 20,000. Part is equal to, well, 0.12 times 20,000. 2,400. So 20,000 minus 2,400 is 17,600. Okay, 17,600. All right. Number 2. If a car lost $3,600 in depreciation in the first year, what is the original cost? Meaning I want to know what is W? So I know my part at 3,600, so 3,600. W is what I'm locating, and my percent I know is at 12 or equal to 0.12. Okay, let's go ahead and keep using our equation. So part is equal to percent times the whole. Well, I know my part is 3,600. I know my percent at 0.12, and I'm trying to locate W. So I'm going to get W by itself. So I'm going to divide by 0.12 on both sides to get that my total, so 3,600, yep, divided by 0.12. My original car was worth $30,000. $30,000. All right. Number 3, complete the table to record the value of the car that cost $50,000 and it depreciates at the rate of 12% per year for the first 5 years. Okay, so at time 0, I have 50,000. Okay, so after 1 year, I need to do 50,000 times 0.12. Okay, so I'm going to do 50,000 times 0.12, and I'm going to get $6,000. Okay, so I need to take this number of 50,000 minus 6,000, and I'm going to get $44,000. Okay, now I'm going into year 2. Well, at the end of year 1, it was worth $44,000. My car is no longer worth $50,000. It's only worth $44,000. So I have to start with $44,000 here times 0.12 because it's going to depreciate by 12% each year off of the original of what I start with. So I start year 2 off with $44,000. Okay, you back up some. All right, so 44 times 0.12, I get, this was 6,000. This was 5,280. Okay, so then I'm going to take 44,000 minus 5,280, and I'm going to get 38,720. So then I'm going to start year 3 at 38,720 times 0.12. So 38,720 times 0.12 to give me 4,646.4. And then I'm going to have to subtract these two numbers. 720 now minus 4,646.4 to get 3,407.60 cents. And do you guys see the pattern here? We're going to take this number times 0.12. So times 0.12 to get 4,088.83. I'm going to round to the nearest hundredths. And I'm going to take these numbers and I'm going to subtract them. 0.6 minus 4,088.83. To get me 29,984.77 cents. And then after year 5, 984.77 times 0.12 is what? 3,598.17. So 29984.77 minus 3,598.77. Or no, that's 17. So after 5 years, at a 12% decrease each year, my car will now be worth $26,386.60. So I start at $50,000 and I now end up almost at half of the original cost after 5 years. Really close to it. Okay. All right. Number 4, complete the graph. Well, here's the thing. The way that my graph is going to look is it's going to start here because I start at 0 years. I'm going to start at $50,000. Okay. At 4 years, I start at $50,000. Okay. After 1 year, I'm at 44. So I'm just under the 1. And then I go down and go down and go down. Now, here's the thing. I'm going to show you what a graph looks like, and it's going to kind of look something like this. Okay. It's going to kind of go sloping down. All right. Now, we can connect the dots in here. It says, would it make sense to connect the dots or connect the points on the graph? If so, connect the points and explain your reasoning. So I have connected the points and then I've drawn a line here. The reason why it makes sense is because time and value of my car are constantly changing. Okay, because think about it. Can I figure out how much my car is worth after half a year or 1.5 years or 2.5 years? And the answer is yes. All right. All you would need to do is then you would decrease by 6% of whatever that number is, because it's 12% each year. So connecting the dots in this instance is would make sense for you. Now, if I was building a birdhouse, for example, and I go from 2 birdhouses to 3, can I really build half of a birdhouse? The answer is no. So in that instance, you would not really connect your dots there. All right, describe the value of the car. Describe how the value of the car decreases over time. So what we noticed here, okay, what we noticed here is that from 0 to year one, I decreased about $6,000. And then from 44 to 38, I went down about, a little, maybe 4,000, and then like 3,000 and things of that nature. So when looking at how my car, the value of it decreases, we can say this. My first year decreases the most, and after that, I would decrease gradually by a smaller number. Okay, by a smaller number. All right. Let me make sure, checking all my messages here. Okay. And then the last one is the relationship between the time and the car's value proportional. Explain how you know with the graph. So looking at the graphs, is this proportional? Well, no. The two things that gave it away is the first thing is 1, it doesn't go through the origin. And 2, it's not a straight line. So no. Okay, it is not proportional. If you guys have any questions over any of that, please let us